welcome back, guys. So let's head over to lecture 2. So in lecture 2, we are going to be talking about nothing but power semiconductor devices. So these are mainly electronic switches, or these are solid state switches. A little bit later on in the course, I will clarify why we care so much about switches in power electronics. So today let's just have power semiconductor devices. So majorly these are switches. These are switches. Majorly these are switches, and these are solid. These are solid state switches. Solid state simply means something that has zero moving parts. So these are solid state switches. These include diodes. We had a brief look at these when we are introducing the course. We have diodes. We have, let me make thyristors, or what we call silicon controlled rectifiers, SCR. Okay, then we happen to be having what we call triacs. Triacs are also switches, solid state. These ones are mainly used to control AC circuits control. So they're using AC circuits control, like phase angle control, where we have to control how much power goes to a load by controlling the average voltage, right? Another one, these are transistors, power diodes, power thyristors, power triacs, power transistors. So power transistors include subcategories. We have MOSFETs. These are metal oxide semiconductor field effect transistors. And we happen to be having BJTs, bipolar junction transistors. And we happen to be having also IGBTs, insulated gate bipolar junction transistors. So MOSFETs, we will look at MOSFETs. These ones happen to be having N channel and P channel MOSFETs. BJTs happen to be having PNP and NPN BJTs. So IGBTs we have the P type and the N type. So let me go backwards on my own words, kind of falling on my own sword. Let me reveal a little bit why we are so much interested in power semiconductor devices or switches. Power semiconductor switches. Why are we so much interested in these solid state switches? Why? In power electronics field of engineering. So, like the definition said, power electronics is a branch of electrical engineering that deals with the manipulation of power. That means we can either manipulate voltage or current or any other related parameter to power with the help of passive and semiconductor devices. So that means at one point we will need to use one of these or a combination of those to manipulate power. Let's say it could be power delivered to an electric motor, DC or AC. It could be power to a heater. It could be power to anything, another electronic device. So it could be power to a couple of LEDs. So that's how we implement things like brightness control, speed control, temperature control, and so many things in industrial setups and domestic setups. So we are going to implement the power manipulation with a few techniques that involve, I'm not going to get into those techniques right now, that involve using one or more than one of these as switches. For example, transistors, we all know by this point in time that transistors can either be used as switches or signal amplifiers. So we can use them either as this or this, but in this case, we are so much interested in the switches part because we are to use it as a switch to manipulate power. We will see later on what we call converters. So these are just circuits that convert power from one form to another, either by manipulating voltage or current. Let's say we have a circuit or a converter that converts AC voltages to DC voltages. So we may have, let's say we want to power a radio or sound system at home, or we want to control a DC load for whatever reason. It could be a DC pump, it could be charging batteries, let's say in a PV system, in a photovoltaic system, that is the solar system. We need to manipulate the power coming from let's say the solar array or what we call panels. So at one point, we will need to adjust how much voltage goes to the batteries to charge the batteries, hence manipulating the current. So that way we can manipulate the power. So if you've ever heard of common terms like MPPT, maximum power point tracking charge controllers, these are nothing but circuits that convert power from one voltage to another at a specific current to give a specific power output. So that is very, very, very interesting because there is an entire section that is the renewable energy field of electrical engineering that depends on power electronics. So I think I've justified enough why we need to look at these devices individually before we set off as switches, regardless of their other alternate applications. So we will later on compare them later on compare them, so that now when we start the conversion part, the converters that convert AC to DC, DC to AC, DC to DC, AC to AC, and manipulating other parameters in between like frequency, phase, and so many. So we will need to understand how these ones operate before we go to the applications. So it's like going to war with weapons we barely understand. Trust me, even if the enemy is to come with barely nothing, like literally nothing, or sorry, barely anything, we will have lost the battle because we do not know how to use what we have. So that is what we're going to do in the consequent lecture. So though, before we wind this mini lecture and get right to the next one, I wanted to point out something. If we look at these switches, there is something in form of a category. Let's think of it as a category. We have what we call controlled switches and uncontrolled switches. So controlled switches are ones where they are turned. For these ones, they turn on and off conditions, turn on and turn off conditions are fully controlled. That's very, very important. That's very important. So the uncontrolled switches, let me do it like this. The uncontrolled switches, on the other hand, they turn on and or off conditions. They turn on and off conditions are not controlled by the engineer, the technician who's using the device. So, for example, controlled switches here could be thyristor. This is controlled switch. A triac is also a controlled switch. Transistors, these are controlled switches. IGBT is also controlled switches. We have one odd man out who is not a controlled switch. So we will look at applications later on that completely exploit the feature of a device being uncontrolled versus controlled. One more thing before we close this lecture. There is one more device we will look at. Let me squeeze it around here. That is what we call an optocoupler. Optocoupler is also a controlled switch. It's some kind of switch that relies on opto means optics, coupler means relating. So we'll look at what an optocoupler. It will somehow fit in this whole paradigm. So guys, let me keep these lectures shorter and shorter, very easy to consume. So let's stop here and right on to the next lecture. Thank you.